Okay, so here's problem 12. And instead of using the double angle rule, we have to use the triple angle rule, which I didn't know existed, but it does. And this is what the identity leads you to. So I suppose the rule is, if you've got a polar coordinate equation and there's a coefficient in front of theta, like 3, a constant, you've got to use the triple angle rule, which leads me to wonder if this was sine 4 theta. I guess you could use the double angle rule twice somehow, but that would be very messy. But anyway, that's an interesting question. What if it was sine 4 theta? I'd have to think about that. But anyway, we can use the triple angle rule. It's not going to be pretty, but what you want to notice here is this 3 sine theta, that wouldn't be bad at all, obviously, if that was the only thing. But we've got a sine cubed over here, this term. And what that means is you've got to multiply both sides by r cubed. And that's when it's going to get a little messy, but that's the only thing you can do, I think. I don't think there's a better answer. So the left side becomes r to the 4th. Then you've got r cubed 3, let me say 3r cubed sine theta minus 4r cubed sine cubed theta. Okay, now for this term here, in a sense, you only need one r to get rid of the sine theta. I think you know what I'm saying. So it's 3r squared times r sine theta, which is y. And over here, you've got an r cubed times a sine cubed theta. Well, that's basically y cubed. So it's 4y cubed. And then r to the 4th, that's x squared plus y squared squared. And then you've got 3 times x squared plus y squared times y minus 4y cubed. And you can simplify the right side a little bit. It's 3x squared y plus 3y cubed minus 4y cubed equals 3x squared y minus y cubed. And again, I don't know if there's much point in simplifying this further. You could take the square root of both sides. That doesn't seem like a great idea. You could certainly multiply out the left side. It would be x to the 4th plus 2x squared y squared plus y to the 4th equals all of this on the right. But yeah, I mean, you could rearrange this, but at least you don't have to isolate y. That's nice of them. So I think the bottom line is these equations in polar coordinates, it's interesting how well they can simplify what would otherwise be a very complicated equation in rectangular coordinates. And maybe that's the point. Maybe that is supposed to help you see the value of polar coordinates in terms of writing another way of taking it's a way of taking a very complex equation and writing it in a much simpler form.